All right. Maybe we just wait for a few moments. So I'm going to click the share button. So this is 2 page. All right. Hello and welcome. How is everybody? The light is not. Need to a bit. Okay. Can anyone hear me?
Yes.
Okay, thank you. It is Celine, right?
Yes, that's correct.
Okay, excellent. It's just, so who are Shamsa here, Celine, okay. Can we just wait for a few more seconds?
No worries.
Okay, thank you. All right, so today's topic, before we start, are there any questions? Anything?
In regards to the final exam, what ways do you think that would be good to prepare for it, besides the MyStat Lab?
Besides MyStat Lab, remember I posted practice final exam questions. The final exam would be similar to those questions. If I were you, I will go over those 54 questions, make sure I understand each and every question.
Perfect, thank you so much.
That is the first step. Second step, I will go the examples on the online modules. If I have more time, I will go over the textbook example questions. Okay. Remember the format of the final exam is multiple choice questions. Any other questions?
Thank you.
You're welcome. Any other questions? Okay, so today is multiple regression analysis. We are going to explore the relationship between one dependent variable, y, and 2 or 3 independent variable x. So for example, you have x1 and you have x2. And I will give you an example. Suppose y is the sales and x1 is the price, x2 is the advertising cost, okay? Advertising. I want to explore, is there a linear relationship between sales and price and advertising? So as you can see, I have one y, but I am dealing with 2 different x. This is an example of multiple regression analysis. Okay, so I will use y. For example, I will use y is the sales equal to, maybe I will say B0 is the intercept plus B1 x1 and then plus B2 x2. this is the equation. If the question is about the model, you have to use capital Y, and you have to use beta 0, okay? And you use beta 1 represent the slope for x1, and beta 2 represent the slopes for x2. And also you have error term epsilon. Okay, so the first one refer to the model. Okay, so the model is always targeting population. The second one is the equation, and the equation is about sample data. When you do a hypothesis test, you always targeting population. So the coefficient, you should use the beta 0, beta 1, and beta 2. Okay, so now let's go back to this equation here. And how do I get this equation? Suppose you are given the data. Okay, so suppose I'm going to give you some data here. So suppose I have a sales data, and I have price and advertisement. Oops. Advertising. So I'm going to maybe randomly jump in some data, okay? 350 is the sales, 460, maybe 460, 340. I just randomly type in some numbers, okay? Just get the idea, okay? So those are the, oops, I suppose those are the sales. So those are my sales, oops. Sales data, okay? And based on sales data, and also I have a price, okay? So just, I just randomly created some numbers, okay? And also you have advertising cost, okay? Just going to randomly type in some numbers. And 2 more data. Okay, so now I'm going to explore the relationship between sales and the 2 variables, 2x. One is price, the other is advertising. So I'm going to produce something like this, linear equation, okay? So how I'm going to do that? I go to data, and then data analysis. After that, regression, and click OK button. Input Y, so this sales is my Y. And input X, X I have 2. One is price, the other is advertising. So you select both price and advertising together. As you can see, I include the labels. Okay. So I'm going to put the output maybe right here, okay, in quick cell. D1 is my output. I have to retype in the Y range. Okay, so now I click OK button. So this is the summary report, as well as the ANOVA table is here. Okay, so let's answer our first question first. how do you produce this linear equation? Okay, you can, by the way, to save some time, I assume this linear model have met the conditions. Those conditions are similar to simple linear regression analysis, okay? For example, the error is independently distributed, and also the variance across the errors has a constant variance, okay? So we assume those are satisfied, then we can say, based on the data, I can produce the equation, okay? And the equation would be based on those coefficients here. My computer. Okay, you see my B0 is 170. Price, the slope for price B1 is 53. Advertising is negative 15, okay? So I'm going to write down my answer here. So sales is Y equal to B0 is 170 and B1 is 53. 53x1, x1 is the price, and B2 is negative 15, x2. Once I have this equation, I can make prediction. For example, when the price is, suppose the price is 5.7, when x1, the price is 5.7, and when x2 represent advertising, okay, just suppose it is 3.9. So this is 1, okay, and you can predict sales Y, and by just plugging this x1 with 5.7 and this x2 with 3.9, you can get the predicted Y. Is that clear? How do you get this linear equation? Okay. And also the outcome here, every number is important. Some terminology are similar to simple linear regression. For example, this multiple R, oops, this is not this one. The multiple R 0.55, that means there is a moderate relationship between dependent variable and independent variable. Here we have two independent variables, price and advertising. Okay, R squared 面说 how much changes in Y can be explained by combined X. In this example, 0.30, it is the same as 30%, means 30% changes in sales can be explained by price and advertising. Okay, and you have a standard error. Okay, standard error is just the square root of MSE here. Okay, if you take square root of this number MSE, mean square for residue, for error, okay, you get standard error. Okay. The relationship in this ANOVA table exactly the same as we did last class for simple linear regression. Okay, so I will not go over it. Maybe I can briefly go over it by try to copy the screen so that I can make annotation. Right. Okay, this is our result. Okay. This degree of freedom for regression, we use letter K. k equal to 2. K represent number of independent variables. Here we have two independent variables. One is x1, the other is x2. So k equal to 2. Okay. And this strategy, this is last one, the degree of freedom for total, it is sample size minus 1 equal to 5. Here we have sample size 6. See, observation 6. This is sample size. Sample size, we have 6. Okay. And then this degree of freedom for residue, it is n minus k minus 1, n minus k minus 1 equal to 3. The final exam will have some questions to ask you to show what is, if I missed one number, you're supposed to figure out, okay? So you need to understand what is k. K represents number of independent variables. What is n? Sample size, okay? And what is this, the first degree of freedom is degree of freedom for regression. The second degree of freedom, 3, degree of freedom for error, for residue, error. The last one, 5, degree of freedom for total, okay? And over here you have SS, and this is a degree of freedom for regression, as due to regression, SSR. Okay, so this number is, or maybe I want to use a pen. Let's see. Okay, so this number is S. It is too thin. Sum of square due to regression, SSR. The next number, the number below it, is sum of square due to error, SSE. Okay. And the next followed by MS. The first number here is MSR. Okay. MSR equal to SSR divided by K. You need to know this. There are 3 items here. In final exam, I would give you 2 of them. I ask you to fill out the missing one. Okay. So next number, this number here, that is MSE, mean square due to error. And how do you get this one? You use SSE, sum of square due to error, divided by n minus k minus 1. So actually you use this number divided by 3, you get this number. Okay. And the next one is the important test statistic for F. F is just a ratio between MSR and MSE. Okay. So if you use this number, divide this number, you get 0.66. And significant F, it is just the p-value, p-value 0.5. Okay. So this is the ANOVA table. Any questions? And the next one, we already explained these 3 numbers. Based on these 3 numbers, the first number is the intercept B0. The second number, the slope for X1. The last number, slope for X2, B2. Okay. And you have a standard error. Standard error, the important number has 2. One is 46.96, and we use the notation S then subscript B1, standard error for B1. Okay. And this AD1, it is a standard error for B2, AD1. You are going to see this notation in the textbook and in online modules. And the next one is test statistic. The first one is 1.146. Okay, this test statistic is for price. Remember, price is our X1. Okay, and the next one, negative 0.18, that is for advertising X2 test statistic. If you wonder why we have F test statistic here, this is my F test statistic. And here I have T test statistic. What is the difference? The difference is F test statistic to test overall model, and the T test statistic to test individual variable. So T test statistic in this case to test the price, to test advertising. This F is overall, test the combination of price and advertising. The T test individual price, individual advertising. Okay. And the next is the p-value for price, p-value for advertising. Okay. And over here, you have confidence interval. Okay, why you have two confidence interval? You have two. One is for prediction interval. Okay, you are going to see. Just want to find here. One is for individual confidence interval. The other is for prediction interval. Okay, so that's why there are two. So basically, you need to understand everything outlined here. And also in this chapter, you need to know the formula for adjusted R squared. Okay, so the formula is, I'll write down here. Adjusted R squared, so I'm going to use RADJ. Adjusted R squared equal to 1 minus, okay, bracket, and then 1 minus R squared multiple R. This capital R is the same as R, okay? So there is a name linear correlation coefficient. These are linear correlation coefficient, okay? And then multiply sample size minus 1 divided by sample size minus number of independent variable K minus 1. Okay. This is the formula for adjusted R squared. Okay. So this is adjusted R squared, and also the variations, different variations is the same as simple linear regression. It means if you have Y, okay, and if you have X and YI is original data, and you have Y hat, predicted Y means Y hat, and you also have an average Y bar. Okay, so suppose Y bar is here, and this is your YI, and this is Y hat, this is Y bar. Okay, remember last time we talked about from here to here, that is the sum of square due to error. Okay. And from here to here, that is the sum of square due to regression. And over here, from here to here, it is SST, sum of square due to total. The relationship is sum of square due to total equal to SSE plus SSR. This holds true for not only simple linear regression, but also for multiple linear regression. Okay. So this is the number of variations. Okay. Next one is about influence on regression. So this is the So we are going to ask question, is there a relationship between sales and price? Because we have 2x, so we have to hold another one constant, holding advertising constant. This is one question, okay? And the other question, is there a relationship between sales and advertising? Holding price constant. Advertising typo here. So let's answer the first question. The second question would be similar, okay? So let's call this is question 1, and this is question 2. So to answer question 1, we can do 5 steps. Step 1, we say H0, we set up null hypothesis and alternative hypothesis. Okay. Because the first question is targeting this is between sales and price. Okay, so we are going to say beta 1, H0 is beta 1 equal to 0. That is null hypothesis. H1 said beta 1 not equal to 0. Okay, so that is our H0, H1. Any questions so far? So that is step 1. And step 2, set alpha. Okay. So if alpha is not given, you assume alpha 0.05. Okay. Okay. And step 3, you calculate test statistic. And this test statistic, you use T, test statistic. The formula is B1 minus beta 1 divided by SB1. So where is B1? You go to your output here. See, B1 is here, 53. 53.84, that is your B1. Okay. So 53.4 is your B1. And what is beta 1? See, beta 1 is 0. You assume beta 1 is 0. Later on, you can reject or you accept. Okay, so minus 0. Divided by SB1, standard error for slope. Where is SB1? See here, 46. SB1 is 46. This is SB1. Okay, 46.96. And this is your test statistic. The result must be this number here, 1.146. You can verify, okay? So this is test statistics, step 3. And step 4, critical value. Critical value for T, not for Z, not for F. Okay, not for chi-square, it is for T, critical value for T. And how do you find the critical value for T? You use your calculator. Your calculator, you need area, usually you use half alpha is the area, and degree of freedom, you use n minus k minus 1. In this case, n equal to sample size equal to 6, k, number of independent variables, 2, minus 1 equal to 3. Okay, is your degree of freedom. So I'm going to grab my calculator. So this use this calculator. Okay, so let me see. You press F5, F2, F3. So F5, F2, F3 on your calculator. Area 0.025, degree of freedom 3, and you get critical value 3.18. Okay. So 3.18 is the critical value. So this is step 3. And step 5, draw conclusion. To draw conclusion, you'd better to draw a diagram. Okay, this is T distribution. In this T distribution, you label the critical value. Let me draw the x-axis. Critical value is 3.18. This is critical value. Critical value decide rejection region. This is rejection region. Critical value decide rejection region. And now, label your test statistic here, 1.146, maybe here. Okay, so this is 1.146. So because test statistic is not in the rejection region, so you do not reject H0 or fail to reject H0. Do not reject H0. Go back to see what is H0. H0 said beta 1 equal to 0. Do not reject this. Okay, so that means there is no linear relationship between sales and the price. When you have a beta 1 is 0, that means no relationship. No relationship. Okay, relationship. So we answer this question. The question said, is there a relationship between sales and price? The answer is no, no relationship, because we do not reject H0. So these 5 steps is a critical value method. And you can also use the p-value method. Oops. For p-value method, you compare p-value with alpha. Okay, so where is p-value? Here. If you go to output here, see, p-value for price 0.33. P-value is 0.33, okay? So p-value equal to 0.33. Obviously, this p-value is greater than alpha. When p-value greater than alpha, you conclude, do not reject H0. Same conclusion as we get from critical value method. Okay, this is p-value method. Any questions? So we answered first question. The second question exactly the same, except I'm going to use different color. When you try to answer the second question, your H0 becomes, what is your H0? It is beta 2 not equal to 0. And H1, beta 2 not equal to 0. When you answer the second question, because second question is about sales and advertising. Okay. And then here, test statistics, you have to change it to B2 minus beta 2 divided by SB2. You have to make changes. Okay. So that is the influence on regression coefficient. Okay. So basically, that's pretty much about multiple regressions. Okay, multiple regressions. The only thing I want to emphasize, remember I told you there are two confidence intervals here, lower, upper, lower, upper. Why there are two? Okay. One is confidence interval for average y given x. Let me see. Y given x. So the first one, CI, this is the second one. Although the number is the same, but for some questions, they're not the same. So the first one is confidence interval for the average y given x. So I'm going to type up here. Confidence interval for the average y given x. And the second one is a prediction interval for an individual y given x. So this one is here. So that is the only thing I want to point out. So in summary, what we did in this lecture, we did multiple linear regressions. We talked about, how about if you have 2x, okay? If you have 2x, actually there are 3 questions here. I can ask you. The third question here, is there a relationship between sales and combined? Is there a relationship between sales and combined price and advertising? That is a research question. To answer this question, you need to use F test. Where is my F test? Remember the output, see here. You need to use this test statistic F or use the p-value for F to answer the third question, overall model. Okay. So that's all for this lecture. Any questions?
I have a question in regards to the SPSS project.
Yes.
So my group, we already finished our assignment. However, our page limit, it's only reached to 9 pages. And on the outline, it says that everyone should be having 10 pages.
Yes, maybe you want to do, I'm not sure what technique you use. Are you using chi-square, t-test, f-test, or regression? Maybe add a little bit more analysis.
Okay, so we did the pair t-test sample, so maybe we can do another analysis, I guess?
Not necessarily another analysis, just give more details about paired sample t-test.
We've done a partial of the data just so because with the paired t-test we needed 2 variables. So we used 2/4 of our table. But it was just, we didn't reach that page limit. So we were just wondering as to what more can we do to reach that 10-page limit.
Maybe, I'm not sure if you use critical value method or p-value method. If you use just one, you maybe need to add another one.
We did both.
You did both.
And we put full explanation about the background, and we did analysis even written for the.
Yeah, then you may want to consider what is the limitation. Maybe it is small sample size. How then, if more data is available, how would that change your conclusion?
Okay.
Okay.
Yeah. Perfect.
You're welcome. Any other questions? All right. By the way, there is now, lecture is ended. So next Saturday would be now Zoom meeting. If you have any questions, please email me with the specific questions, okay? I would be happy to answer your emails. All right, that's all for today. Thank you so much. Are there any last minute questions? Oh, all right. Good night. Thank you for your participation and good luck for the final exam.